So problem number 1 says a 28-gram mass of silver is heated from 15 degrees to 85 degrees C. Calculate the heat energy that was added to the sample. The specific heat of silver is 0.23 joules per grams per degree C. We've already been told that our formula is Q equals M times S times delta T. So let's just go through and assign values to some of those variables. It says calculate the heat energy that was added to the sample. So it's asking us to find Q. That's what we're looking for. A 28-gram mass of silver. So mass is equal to 28 grams. And it's heated from 15 degrees to 85 degrees. So that's a difference of 70 degrees. So our delta T is 70 degrees. And then the specific heat of silver is given to us, and that is 0.23 joules per gram per degree C. Okay, so we just take those numbers and plug them into our formula. Q equals 28 grams times specific heat, which is 0.23 joules per grams per degree C, times 70 degrees. And when we punch those numbers in, equals 450 joules. This actually calculates out to 450.8, but you only have two significant figures here, so you have to round that to 2 sig figs, so you get 450 joules. The grams cancel, the degrees C cancel. Your answer is in joules, which is a measure of heat energy. And that is the answer to number 1. Question number 2, if 5.5 kilojoules of heat is added to 50 grams of water at 25.2 degrees C, what is the final temperature of the water? Water has a specific heat of 4.184 joules per grams per degree C. There's a little typo right here. This degree mark should be over here with the C. Okay, so in this example, Q then is 5.5 kilojoules. The mass is 50 grams. The specific heat is 4.184 joules per gram per degree C. And it's asking us for the final temperature of the water. So we're going to try to find delta T. That's what we're looking for. Once we find delta T, we can add it to the initial temperature and get the final temperature. Okay, and our initial temperature is given as 25.2. Okay, so we're going to rearrange this equation to solve for delta T. So M times S times delta T equals Q. Divide both sides by M times S. Cancel the M and the S on this side, and we get delta T equals Q divided by M times S. Then we just plug in our numbers. Oh, but wait, we have to do something else first. Q is in kilojoules, but S is in joules. And for this equation that we use, Q equals M times S times delta T, we need to work in joules. And and not kilojoules. So we need to take Q, which is 5.5 kilojoules, and convert that to joules. And so we know that 1 kilojoule is equal to 1,000 joules, which gives us 5,500 joules. Okay, so just remember that when you're working with this equation, you need to work in joules and not kilojoules. So if you're given something in kilojoules, you're going to need to change that before you put it into the equation. Okay, so now we have delta T equals 5,500 joules divided by 50 grams times 4.184 joules per gram per degree C. And since we had 3 significant figures here, this number actually has 3 significant figures. Even though we don't have the decimal there, we go back to our original amount and see that it had 3 because of that decimal. So we just need to remember that we have 3 sig figs here, and we have 3 here. So our final answer to this is going to be in 3 significant figures. And the number I got was 26.3 degrees C. Okay, your grams will cancel each other. Your joules cancel each other. You're left with degrees C, which is in the denominator of the denominator. So it flips back up into the numerator, and you get 26.3 degrees C as your delta T. Now the question was, what is the final temperature of the water? So you've got to add that to the initial temperature. These are both degrees. And we get a final answer of 51.5 degrees C. So there's our answer for number 2.